This year, while doing calculations and experiments, and whenever you're dealing with numbers, you are going to be expected to round to the correct amount of significant figures. So that's what we're going to talk about right now. What this video is going to cover is significant figures and measurements, when zeros are significant and when they are not significant, and significant figures and calculations, whether that means addition and subtraction, or multiplication and division. Okay, so significant figures and measurements must include all of the digits that are known plus a last digit that is estimated. So for example, if we're measuring something with a ruler, so we're going to be doing that in centimeters or meters or whatever it may be. But if you think of the length of a regular ruler, it's broken up into centimeters, but it's also broken up into millimeters. If we were to measure something, we would have to say the amount of centimeters, the amount of millimeters, and then our guess of the next digit. So now looking at zeros. Zeros to the left of a number, but in front of non-zero digits are not significant. So an example that would apply to would be this one. So 0.0063. So it's to the left of numbers, so here are non-zero digits, and so it's in front of them, so they are not significant. If they're not significant, we only count the non-zero digits. So our non-zero digits are 6 and 3. So this one would have two significant figures. You may notice that I abbreviate significant figures with sig figs. Zeros between non-zero digits are significant. So in this case, we have a 0, but it's in between two non-zero digits. So in this case, we would have 4 significant figures. Okay, zeros to the right of a number and after a decimal place are significant. So we can see here that these two zeros are to the right of non-zero numbers, and they're to the right of a decimal place. So here, all 4 digits are significant. Zeros to the right of a number, but to the left of a decimal place, are not significant. So we could pretend that there was a decimal place here, just as if it were at the end of a number. So here, it says that to the right of a number, but to the left of a decimal place, which is how these zeros are, they're not significant. So only our non-zero numbers would be significant, making this 2 sig figs. Okay, now let's look at significant figures and calculations. A calculated answer cannot be more precise than the least precise measurement from which it was calculated. Which makes sense, because if you're measuring something, your calculated value cannot be more accurate than what you measured. So when we do addition and subtraction, it's going to have a different rule than if we did multiplication and division. So let's look at addition and subtraction first. The calculation should be rounded to the same number of decimal places as the measurement with the least number of decimal places. So when you're looking at addition and subtraction, you're counting the amount of decimal places that there are. So let's do one example together, and then for the second example I have the answer up that you can try on your own. So here we have 41.3 plus 0.398 plus 11.24. So what we want to do is we want to add these all together. Okay, so when we add these all together, we get 52.938. But we know that when we do addition, it has to be to the least amount of decimal places. So if we look at what our question was, 41.3 has the least amount of decimal places, having only 1. So what I'm going to do is our final answer is going to be 52.9. In this case, it's going to stay 9 because the number next to it is less than 5. If it was 5 or greater, you'd round your 9 up 1, making it 53.0. So this next one. Find the total mass of 3 chocolate bars that have masses of 2.40 grams, 2.32 grams, 1.743 grams. The answer is 6.46 grams. Hopefully you got that answer. If not, try it again, see if you can get the correct answer, but if not, we can go over it.
Yeah, he said no. Okay.
Alright, so next let's go over multiplication and division. Calculation should be rounded to the same number of significant figures as the measurement with the least number of significant figures. So multiplication and division differ slightly from subtraction and addition, saying that here we're looking at significant figures, whereas in addition and subtraction we looked at decimal places. So let's try a sample problem. Like we just said, multiplication and division, we're looking for the least amount of significant figures. So here, if we were to plug 21.34 times 5.40 into our calculator, we would get an answer of 115.236. So looking for the least amount of significant figures. So 21.34 has 4 significant figures, and 5.40 has 3 significant figures. So we need to round our answer to 3 significant figures. So in order to do that, we would get 115 as our answer. Make sure everyone can read it. So this next one, you're going to try on your own. I already have the answer up for you, but make sure you get the right answer, and if you don't, try it again, and if you still don't understand it, we can go over it in class. Calculate the volume of a box whose sides are 3.4 meters, 2.04 meters, and 4.7 meters. The answer I got was 33 meters cubed.